The topic is time, speed, distance. Look at this question here. If you think the answer is 50, that's not correct. The answer is 48. We will be solving this question later in the session. The basics. Speed equals distance divided by time. Average speed equals total distance divided by total time. Let's learn by examples. Look at the first example here, the same question that we had on the first slide. Let the distance one way be d. Therefore, the distance covered is d one way, d coming back. Therefore, total 2d. Total time is d divided by 40 while going, and d divided by 60 while coming back. Total distance, 2d. Total time taken, d divided by 40 plus d divided by 60. Average speed is total distance divided by total time. So the average speed is going to be this much. See, all the d's will get canceled, and you will get a numerical answer, 48 miles per hour. Look at this now. 2 questions here. Total distance here is going to be in the ratio 1 to 3. So let's assume the smaller side is k. The bigger side becomes 3k. The total distance covered, therefore, would be 8k. 8k is the total distance covered. Total time taken would be, along the shorter sides, k plus k equals 2k. That's the distance. Speed along the shorter side is 20. Along the longer side, the distance is 6k, and the speed is 40. All the k's get canceled. We just have to be a bit careful with the calculation here. This turns out to be 320 divided by 10, and that is 32. So the average speed is 32 kilometers an hour. Let's look at the second part. Time spent along length. Length is the smaller side. So 2k divided by 20 is the time spent. Along the longer side, it is 6k divided by 40. So to remove the denominators, let's multiply both the terms with 40. Turns out to be 4k, ratio 6k. Therefore, the ratio is 2 to 3. These are the correct answers, 32 and 2 ratio 3. Another example here. 2 questions again. Please try solving it yourself. A smart way of solving this would be to figure out that t1 minus t2 equals 1. t1 would be d divided by 24 when he goes at the speed of 24. The distance is same the second time also, and this time the time taken would be d divided by 30. And this difference is equal to 1. So you can solve it for d. You figure out that d is 120. And time taken to reach his office at 30 miles per hour. Therefore, it would be 120 divided by 30. That would be 4. So yes, quite simply, d divided by 24 minus d divided by 30 equals 1. Find d. That's the catch. Relative speed is the topic. Here is a question for you. Did you get 50? Did you get that in like 20 seconds? If not, wait for the video to get over and attempt this again. Basics. Relative speed is the sum of the speeds of two bodies when they are moving in opposite direction, and it is the difference in the speeds of two bodies when they are moving in the same direction. With this concept in place, let's move on to learning by examples. Here is the first question. Please pause the video, solve it yourself. This has several parts. A conceptual question that will help you solve many questions on these lines. So there's one train, 100 meters long, moving from east to west direction. This is 100 meters, and the speed is 20 meters per second. How long will it take to cross? The first question, another train, 200 meters long. This train is 200 meters long now, moving from west to east, and the speed is 10 meters per second, and the distance between the two trains is 600 meters. See, the term is cross, and therefore the total distance to be covered is 600 plus 200 plus 100. So first question, the distance is 900, and since they are moving in the opposite directions, speed would be the sum of their speeds. 10 plus 20 equals 30. So the answer is 900 divided by 30 equals 30 seconds. Look at the second one. The same question, It's just that now the direction is not west to east, it is east to west. So it's moving this way. The distance to be covered is still 900, but the relative speed is the difference of the two speeds. This train will overtake this train at 20 minus 10 equals 10 meters per second. The time taken would be longer. It would be 900 divided by 10 equals 90 seconds. Third question. This train, they say, is stationary. So the speed would be 0 meters per second. Distance to be covered is still 900. And the speed is simply the speed of the first train, 20 meters per second. Therefore, the time needed is 900 divided by 20 equals 45 seconds. The last question. This time, it's about a pole, 1 kilometer away. So now the distance to be covered is 1,000 plus 100 equals 1,100. And speed would simply be the speed of the train, that's 20. So the answer is 1,100 divided by 20 equals 55 seconds. So this was one conceptual question with several parts that actually explain the concept of relative speed and multiple cases that show up on the test. Next example. Please pause the video, solve it yourself. There are two parts to this question. First part, 50 miles down the stream. When the boat is going down the stream, the current would help the boat in moving faster. Therefore, down the stream, the time taken would be 50 divided by sum of the two speeds. So 50 divided by 20 plus 10. And for coming back, the time taken would be 50 divided by 20 minus 10, because now the current would resist the boat in moving, and the speed would effectively be the difference of the two speeds. So 50 divided by 20 plus 10. That is 5 divided by 3 plus this is 5. So it turns out to be 20 divided by 3 hours, or 6 hours 40 minutes. The answer is 6 hours 40 minutes. Let's look at the second question. 2 hours down the stream, the person would be traveling 2 times 20 plus 10, and up the stream, the person would travel 2 times 20 minus 10. The boatman traveled 60 miles down the stream and traveled back 20 miles up the stream. Therefore, the person is 40 miles away from the starting point. So the answer is 40 miles. Look at this example. Please pause the video, solve it yourself. There are two parts to this question. Now imagine there is a circular track, and two friends are starting from a starting point. There's one boy who is a bit slower, and there's another boy who is a bit faster. Now imagine what would happen as they start running. The gap between the two would keep on increasing, and there would come a time when the gap would be so much that it would be equal to a complete circle. That is where they will meet again. So the number of times they meet would be the number of times the faster boy overtakes the slower boy. So let's figure out how many rounds they each are taking. The faster person will complete a round every 200 divided by 4 equals 50 seconds. And the slower guy would complete it in every 200 divided by 2 equals 100 seconds. They are running for 10 minutes. So the faster boy would complete 600 divided by 50 rounds. 10 minutes means 600 seconds, so 600 divided by 50. The faster boy would take 12 rounds. The slower boy runs at half the speed, so he would complete half of this. He would complete 6 rounds. So when they move in the same direction, they would meet 12 minus 6 equals 6 times. What happens when they move in the opposite direction? Now see what would happen. The slower boy runs this side, and the faster boy this time runs this side, the opposite side. So what would happen? This boy is a bit slower. He will keep on moving at a slower pace. The faster boy would cover the circumference at a faster pace, and therefore somewhere here they will meet. So see, nobody has completed a complete circle, but still they have met because together they have completed a circle. Therefore, every time they together complete a circle, they would meet. So if one boy completes 12 rounds and the other boy completes 6 rounds, together they complete 18 rounds. And that is the number of times they will meet when they are running in opposite directions. So the two answers are 6 and 18. A session on work, type 1. When work is not defined, and therefore we can assume the work to be 1 unit. Look at this question here. How do we solve this? Tap A fills in 20. So 1 divided by 20 for A, plus 1 divided by 10 for B. For C, it is 1 divided by 20. All of this times, let's say K hours, is what it is going to take. So this is equal to 1. The value of k is 10. Therefore, the 3 taps will together take 10 hours to complete this. In case you didn't get this too well, don't worry. We will start from the basics. Let's look at the underlying concept. A question on the same. A takes 10 minutes to do a job. B takes 30 minutes to do the same. How long will it take to complete the job if both work together? This is a type that we have been solving since the school days. The underlying approach is that in such questions, assume the total work to be 1 unit. So if A takes 10 minutes to do the job in 1 minute, he would do 1/10 of the job. B takes 30 minutes, so in 1 minute, B would do 1/30th of the job. So in 1 minute, together, they would do 1/10 plus 1/30th of the job. So assume that they take k minutes to complete the job. Therefore, k times 1/10 plus 1/30th should complete the work. And this should be equal to 1. 1/10 plus 1/30th is the amount of work they're doing in 1 minute. And if they are taking k minutes to complete the work, then k times 1/10 plus 1/30th being equal to 1 should give us the value of k. That is the number of minutes they would take together to complete the job. So solve this for k. You get 7.5. That is the amount of time they would take to complete the work together. Let's go on to apply this concept on some live questions and learn by examples. Please pause the video, solve it yourself. That's quite straightforward. A takes 10 minutes, B takes 20, and C takes 30. So suppose they will take k minutes to complete the work together. Therefore, k times 1/10 plus 1/20th plus 1/30th equals 1. Solve it for k. That's a very simple question. We will be increasing the difficulty as we proceed. So k times 6 plus 3 plus 2 divided by 60 equals 1. K turns out to be 60 divided by 11 minutes. Look at the next question now. Please pause the video, solve it yourself. A can fill it in 5 hours. B can fill it in 10 hours. C can empty it in 20 hours. So 1/5 plus 1/10 minus 1/20th, because if filling is positive work, then emptying is negative work. Negative 1/20th. This is the amount of work they do together in 1 hour. Therefore, if they take k hours to complete the work, then k times this sum should give us 1, the total amount of work that we assumed. Now simply solve it for k. That's also quite straightforward. K times 4 plus 2 minus 1/20th equals 1. So k turns out to be 4. That's the right answer. Look at the next one now. Here, emptying the tank is positive work, and therefore filling would be negative work. The tank is 2/3 full, so the amount of work to be done is only 2/3. If it were to be filled while it is 2/3 full, then the amount of work to be done would have been only 1/3. So 2/3 of the tank is full and all of it has to be emptied. The amount of work to be done is also 2/3. So we will not equate it to 1 this time. We will equate it to 2/3. The amount of work that these taps do together is 1/24th, being positive work, plus 1/6th being positive work, and negative 1/12th being negative work. All of this times k shall be equal to 2/3 the amount of work that needs to be done. Solve it for k. So this turns out to be 16/3. That is 5.33. So 5 hours and 20 minutes. That's the right answer. Look at this one now. Please pause the video, solve it yourself. This is a very good question. One of my most favorite questions. I've been giving this to my students for several years now. Please don't take it lightly. This has many traps. Do your best. Please pause the video and solve it yourself. There is a lot to be learned from this question. Tap A can fill in 10 hours, so 1/10. B can fill in 20, so 1/20th. C can empty in 30, so negative 1/30th. This sum turns out to be 7/60ths. 7/60ths is the amount of work done in 3 hours. The 3 hours bit is important to understand because the taps are not working together. They are working one by one. So 7/60th is the amount of work done in 3 hours. The amount of work that practically needs to be done is only 3/4. So 3/4. To make the bases common, 3/4 can be written as 45/60th as the amount of work that needs to be completed. Now, we can't apply the simple unitary method because that would apply if all the 3 taps were working together. Here, they are working one by one. Imagine when the tank actually fills up, only one of the 3 taps will be operational. Okay, so we cannot apply the typical unitary method. We have to bring this closer to 45/60th and then check that which tap will be in action when the tap fills up. We have 7/60th. If we have 6 such cycles of 3 hours each, we will get 42/60th. So 42/60th parts of work have been done, and 6 cycles of 3 hours each have been completed. So how much work is remaining? 3/60th parts of work is remaining, which is equal to 1/20th. And whose turn is it now? 6 full cycles have been completed. So it is the turn of tap A. A completes 1/10th of work in 1 hour, but only 1/20th work is remaining. Therefore, A would take only half an hour to complete this much work. So in all, we have 3 times 6 equals 18 hours here and half an hour here. So total 18.5 hours. The work started at 7 a.m., so the tank would begin to overflow at 1:30 a.m. That's the right answer choice. Look at this one. This is a favorite GMAT type. That there would be a team that would be working, somebody would leave, somebody would join. The right approach to these questions is to just keep on adding the work done hours-wise or days-wise. So A starts working and is joined by B after 2 hours. So first 2 hours, A worked alone, and therefore he must have completed how much work? That's 2 times 1/8 of the work. So A completed 1/4 of the work. He is joined by B. For how long? After 3 hours, something else happened. That means for 3 hours, A and B worked together. Therefore, over these 3 hours, the amount of work done would be 3 times 1/8 plus 1/16. That's 3/16 times 3. That's 9/16. All right, now for the next K hours, B and C work together until the work completes. So K times 1/16 plus 1/12 should be equal to the amount of work left to be done. This is 9/16. 1/4 can be written as 4/16. So 13/16 work has been completed. 3/16 is left. But see, the LCM of denominators here is going to be 48. So rather than 3/16, let's write it as 9/48 for ease of calculation. This will simplify to 7/48. So K times 7/48 equals 9/48. 48s get canceled. Therefore, K equals 9/7 hours. The question is asking how much more time will they need to work. The answer is 9/7 hours. Some DS examples now. Look at this one. Please pause the video, solve it yourself. The question is, how long will A take to complete a task? Statement 1 does not talk about A, so this cannot be sufficient. Statement 2 talks about what A, B, and C together take. So this is also not going to be sufficient. Together, we know that 1 over B plus 1 over C equals 1 over 10 from statement 1. And we know that 1 over A plus 1 over B plus 1 over C equals 1/5 from statement 2. So, on combining, we can subtract the two equations. Please notice, on subtraction, B and C would get canceled. Hence, we can find the value of A. Please don't spend the time in figuring out the value of A. It would be 1/10, but that's not important. The point is that after combining the statements, you will be able to find the value of A, as in how long will A take to complete the task himself. Therefore, combining worked. C is the right answer choice. Look at this one. Statement 1 doesn't talk about A, while the question is how long will A and B together take. So statement 1 is not sufficient. Statement 2 doesn't talk about B, so this is also not sufficient. On combining, what do we get? From statement 1, we get 1 over B plus 1 over C equals 1/10. From statement 2, we get 1 over A plus 1 over C equals 1/20th. Now, if we try eliminating C to get an equation in 1 over A plus 1 over B, that won't be possible because when you subtract the two equations, this would get canceled. But what you will get is 1 over B minus 1 over A, whereas the question requires us to find 1 over A plus 1 over B. This cannot be determined. even on combining. Therefore, even combining did not work. And the right answer is option E. Look at this one. Quite intuitively, one equation in A and B is given in the question. One equation can be formed from statement 1. So we will have two equations, two variables. We will be able to solve it. So this statement is going to be sufficient. Statement 2 gives us the efficiency of B. From the question, we have an equation in A and B. Therefore, if the efficiency of B is known, the efficiency of A can be determined. So even this is going to be sufficient. The answer will be that A will take 10 minutes to fill 100 cans. However, you don't have to actually go about finding that value. The point is that you have one equation from the question stem, and each of these statements give you one equation more. You are dealing with two variables here, so you will be able to solve the question using each statement alone. The right answer here is option D. Second topic under work. This is when the work is defined and we cannot assume it to be 1 unit. Look at this example here. Did you get 10 minutes? And did you get that in like 30 seconds? See, what has happened is that the workforce has been halved. 10 has become 5. But then the work has also been halved. Therefore, the amount of time taken will remain the same. So quite intuitively, the answer should be 10 minutes. Let's start from the basics. Look at it. A basic question here. The approach is that in such questions, define the total work in man-hours or man-days as applicable. So 10 men take 20 days to complete a task, working 12 hours a day. So the right way would be to define the total work in terms of man-hours. So the total work is 10 men times 20 days times 12 hours. This turns out to be these many man-hours. Now case 2. Assume that the number of days the new team will take is K. So 6, the number of men, times K, the number of days, times 10, the number of hours per day, should be equal to the same number of man-hours because the work is the same. This will give you the value of K. So 40 is the answer. But more importantly, conceptually, this is the approach. Please understand this really well. It's very useful. Let's solve one more question. In this question, there is one more catch, that there is an efficiency difference. So see, total work is 10 men working for 20 days, 12 hours a day. So the work involves those many man-hours. 20 women, it is told, are equivalent to 40 men in efficiency, and 30 children are equivalent to 10 men. So the new team effectively has 50 men. They have 16 days to complete the work. So 50 times 16 times H equals 10 times 20 times 12. We can solve it for H. Turns out that the new team has to work just 3 hours a day. Look at this one. In this question, the work done is in form of the volume of something. So total work done would be 50 cubic centimeters per second for 2 minutes. So total work is 50 times 2 times 60, these many cubic centimeters. Now the case 2 is that there are 3 smaller inlets with flow 20 cubic centimeters per second each. So effectively, 3 of 20 add up to 60 cubic centimeters per second. Therefore, amount of time needed would be 6,000 divided by 60. That would be 100 seconds. Now that we have covered the concepts in detail, let's practice some questions. Look at this one. 20 men and 20 women. 20 women are equivalent to 40 men. So 20 plus 40, effectively, we have a team of 60 men. Now 60 men are taking 30 hours. So the work can be defined as 1,800 man-hours. The new team, 60 children, are equivalent to 30 men, and 40 women are equivalent to 80 men. Effectively, 110 men. So 1,800 divided by 110. 180 over 11 is the amount of time needed. These many hours is what the new team is going to take. This was a basic question. We will be increasing the difficulty as we proceed. Look at this one now. 40 employees take 30 days, working 8 hours per day. So the total work is 40 times 30 times 8. Turns out to be 9,600 man-hours. 40 employees start the work, but after 10 days, 20 leave. So for the first 10 days, it's business as usual. 40 times 10 days times 8 hours per day. So this much work has been done. Therefore, 6,400 man-hours of work remains. Now 20 have been replaced by employees who are half as productive. So 20 older employees remain. 20 who join in are half as productive. So effectively, we have a team of 30 men now. 30 men. The work has to be completed on schedule. So we have 20 days left. Total 30 days, but 10 days have gone. We have 20 days. Let's assume that they need to work 8 hours per day. So this product has to be equal to the amount of work remaining, which is 6,400. So this product is equal to 6,400. Therefore, H equals 64 divided by 6. That is 10.66, or 10 hours and 40 minutes per day. That's the answer. Look at the next one now. It's a DS question. 30 men and 45 women, and what's given here is 20 and 30. So it's in the same proportion. We know that the new team is 50% bigger. So if the older team is taking 15 days, the new team would take 15 divided by 1.5 equals 10 days. See, 20 times 1.5 equals 30. 30 times 1.5 equals 45. So this new team will take 15 divided by 1.5 equals 10 days. So statement 1 is very much sufficient. Statement 2 only talks about the productivity. It doesn't talk about the amount of time they take, and therefore statement 2 is not sufficient. 2 is not sufficient. 1 is sufficient. A is the correct answer choice. Look at the next question. In this case, the proportion is not the same. 10 and 20, that's 2 times. 5 and 20, that's 4 times. So statement 1 is not going to be sufficient. Statement 2 alone only talks about the difference in productivity. It says nothing about the absolute time taken for completing the work, and therefore statement 2 is not going to be sufficient. On combining, however, intuitively we can find out that we will get one equation from statement 1 and one equation from statement 2. There are 2 variables, and therefore we will be able to practically solve the question. Together, it would be sufficient. You don't have to actually go about calculating the value. For the purpose of conceptual clarity in this video, I am still solving it. But if it were GMAT, I would not solve it. I would just mark C as the answer choice and proceed. Nonetheless, let me solve it. Women are twice as productive. So 5 women practically become equivalent to 10 men. So total 20 men is the team here. And it is taking 30 days. So the total work is 600 man-days. Now 20 men and 20 women will practically become 20 plus 40 equals 60 men. The work is 600. Therefore, they would need 600 divided by 60 equals 10 days. So the numerical answer is 10, but that's the beauty of data sufficiency. You don't have to reach to the numerical values. You just have to figure out that how much information is needed to solve the question. In this question, you needed both the statements. Therefore, C is the correct answer choice.